So, good day everyone. I am going to continue the report of Chapter 6, the fundamental principles of traffic flow. Traffic flow theory involves the development of mathematical relationships among the primary elements of a traffic stream: flow, density, and speed. These relationships help the traffic engineer in planning, designing, and evaluating the effectiveness of implementing traffic engineering measures on a highway system. So, there are elements of fundamental principles of traffic flow. Traffic flow elements. Um, Let us first define the elements of traffic flow before discussing the relationships among them. However, before we do that, we will describe the time-space diagram, which serve as a useful device for defining the elements of traffic flow. So, time-space diagram. The time-space diagram is the graph that describes the relationship between the location of vehicles in a traffic stream and the time as the vehicles progress along the highway. So, Monogram diagram. Ang sa vertical mo ang distance and the horizontal is the time. So next is the primary elements of traffic flow. The primary elements of traffic flow are flow, density, and speed. Another element associated with density is the gap of headway between two vehicles in a traffic stream. The definitions of these elements follow. The flow, or stands by letter Q, is the equivalent hourly rate at which vehicle pass a point on a highway during time period less than 1 hour. It can be determined by Q minus N times 3,600 over the time to VEH over H. So N stands for the number of vehicles passing a point on the roadway in T, and Q equals the equivalent hourly flow or the traffic flow. Density stands by letter K, and so on. So, and also space mean speed is the harmonic mean of the speeds of vehicles passing a point on a highway during the interval of time. It is obtained by dividing the total distance traveled by two or more vehicles in a section of a highway by the total time required by these vehicles and travel the distance. So, morning ang space means speed diagram. Kilometer per hour. And also by converting kilometer per hour to meter per second, you're just going to divide it by 3.6. So, there are example: determining flow density, time, speed, and space mean speed. The figure 6.3 shows vehicles traveling at the constant speeds on a two-lane highway between sections X and Y with their positions and speed obtained at an instant of time by photography. So you can see the solutions and the process. So T sub I is equals to L over 1.47 u I. T sub A is equals to 300 over 1.47 times 45 equals to 4.54 per second. So the final answer is that 39.0 miles per hour. So flow density relationships. The general equation relating flow density and space mean speed is given as flow density times space mean speed. So you just can read it. Fundamental diagram of traffic flow. The relationship between the density VH over miles and the corresponding flow of traffic on a highway is generally referred to as the fundamental diagram of traffic flow. The following theory has been postulated with respect to the shape of the curve depicting this relationship. So this is the fundamental diagrams of traffic flow. Makita ninyo diyan mga congested flow, mga flow versus density, space means speed versus density. So next is the mathematical relationships describing traffic flow. Mathematical relationship describing traffic flow can be classified into two general categories, macroscopic and microscopic, depending on the approach used in the development of the relationship. The macroscopic approach considers flow density relationships, whereas the microscopic approach consider spacing between vehicles and speeds of individuals' vehicle. So this is the corresponding relationships for flow and density, and for flow and speed can be developed. Since Q is equals to Q key, substituting Q and the square root of U sub S for key in equation 6.13 that I gave you. Yeah. And then ma-read na sa judya. This is for the maximum flow. So, Greenberg's model. Several researchers have used the analogy of fluid flow to develop macroscopic relationships for traffic flow. One of the major contributions using the fluid flow analogy was developed by Greenberg in the form. For maximum flow, dq is over to dk equals to 0, giving ln times Q sub I over Q sub O is equals to 1. So next is the calibration of macroscopic traffic flow models. The traffic model discussed thus far can be used to determine specific characteristics such as the speed and density at which maximum flow occurs and the jam density of a facility. So there's a lot of example. You can also message me for further examples. So this is the speed and density observation of a rural road. This is the table. First is we have a speed, US miles per hour, density, xy sub 1, x sub I squared, so there are this first table shows plot on speed versus density for two estimated regression functions obtained and also for the actual data points. And the other one is the figure shows similar plots for the volume against speed. So the microscopic approach which is sometimes referred to as car following theory or the follow the leader theory, considers spacing between and speeds of individual vehicles. So the gun nyo guys. So balik kung dapit this. Aron injure ang maikuan. So that's it for today. Thank you and God bless you.